Time travel, huh? Okay, buckle up because we're diving deep on this one.
It's funny. What fascinates me about time travel is that even if we never actually cracked the code and build a time machine, just the act of wrapping our heads around the concept, it changes how we perceive the world around us, you know?
I'm intrigued already. So, where do we even start with something as massive as time travel?
Well, I found this NASA article, and it threw me for a loop a little bit. They said we're all time travelers.
Hold on, hold on. I time travel every day. Does my morning commute count? Because I wouldn't exactly call that fascinating.
Not quite that simple. They're saying that we're constantly moving through time, right, 1 second at a time. It's something we totally take for granted. But then, boom, Einstein enters the scene with his theory of relativity, and suddenly that whole straightforward 1 second at a time
Hmm.
thing gets flipped on its head.
Okay, yeah. Let's talk Einstein. I have to admit, relativity always felt a little intimidating to me.
It definitely requires some brain bending. But at its core, special relativity, what it boils down to is this. The faster you're zipping through space, the slower time moves for you, at least compared to someone who's standing still.
Wait, are you serious? You're telling me time isn't constant for everyone?
You got it. And here's the really cool part. This isn't just some theory, it's been proven. So scientists took these two atomic clocks, synchronized them perfectly, and then they put one on a plane, flew it around the world.
Okay.
And when they compared the two clocks again, get this, the one that had been on the plane was actually a tiny bit behind the one that stayed put on Earth.
You're telling me just by hopping on a plane, time moves differently for me than for someone chilling on the ground. That's wild.
It really is. And get this isn't just some wacky scientific anomaly. It actually affects technology we use every single day. Things like, GPS.
Now that you mention it, I do remember reading something about that. How does GPS take into account the curvature of the Earth and everything?
It's not just about the Earth's curvature. It's about the curvature of time itself.
Yeah.
Think about it. Those GPS satellites are zipping around the Earth super fast. Plus, they're farther away from the Earth's gravity. Both of those factors actually make their clocks run a smidge faster than clocks down here on the surface.
So they actually have to adjust for that difference to make sure we're getting accurate locations.
Absolutely, spot on. Without factoring in both special and general relativity, those little blue dots we rely on our maps, they would be way off, sending you to the wrong side of town, maybe even a completely wrong town.
You're saying every time I use Google Maps to find a decent cup of coffee, I'm actually proving Einstein right. That's incredible. It really makes you wonder what other hidden implications of relativity are out there, things we encounter every day without even realizing it.
That's the thing about physics that just blows my mind.
Yeah.
It's not just these abstract equations and theories tucked away in textbooks. It's woven into the fabric of reality itself.
Yeah.
And when it comes to time travel, we're just scratching the surface.
Okay, so we've got Einstein blowing our minds with these theories showing that time isn't this fixed, rigid thing we always thought it was, and that it's actually impacting us in ways we don't even realize. But what about actual time travel? Like the hop in a machine and end up in a different century kind of time travel?
Now that's where things get really interesting. See, Einstein's theories, they open the door to some pretty mind-blowing possibilities, even beyond what we're seeing with GPS.
I'm all ears.
So, remember that Wikipedia deep dive we did? It led us to black holes, those cosmic monsters, right? The gravity is so intense, not even light can escape. Well, it turns out they're not just the stuff of science fiction. They're actually legitimate solutions within Einstein's equations.
Wait, so you're telling me black holes could be the key to unlocking time travel?
It's a possibility, but of course it's not that simple. Let's imagine a rotating black hole, and physicists believe that most of them do rotate. Because of the way its gravity warps space-time around it, it could, in theory, act like a kind of natural time machine.
Okay, now we're talking. That's more like the time travel scenario I was picturing, but how would that even work?
Because of this immense gravity we're talking about, time would actually pass much slower for someone hanging out near a black hole compared to someone far away. So, theoretically, you could get up close to this rotating black hole, not too close, obviously. Spend some time in that warped gravity field.
Let me guess. And when you came back, everyone else would have aged years, decades, maybe even centuries.
Bingo. You'd essentially be catapulted into the future, all thanks to this thing called time dilation. The catch, of course, and there's always a catch, is surviving the trip. Getting anywhere near a black hole is incredibly dangerous, and we're nowhere close to having the technology to even attempt something like that.
Right, besides the whole being ripped apart by unimaginable gravity thing. But let's just say, hypothetically speaking, we could figure that part out. What about going back in time, like a real Back to the Future situation?
That's the real head scratcher. Even just thinking about it theoretically, going back in time using black holes is a whole different ballgame. It might even be impossible, no matter how advanced our technology gets.
Well, so much for having a chat with Shakespeare then. But this is where I find the whole philosophy of time travel so fascinating. Even if we can't actually do it right now, just thinking about these concepts opens up so many questions.
I totally agree. It forces us to confront these really profound philosophical puzzles. Like when I was reading the Internet Encyclopedia of Philosophy, they made this distinction between two types of time travel. Natural time travel, like the black hole scenario we were just talking about, and something they called Wellesian time travel.
Wellesian. Like H.G. Wells, the time machine guy.
Yes, exactly. Natural time travel, even if we managed to pull it off, would still have to play by the rules of physics as we currently understand them. There are going to be limits. You might be able to fling yourself into the future, but returning to where you started or pinpointing a specific moment in the past, well, that's a whole other story. Well, Dosian time travel, on the other hand, throws those limitations out the window. It's time travel unshackled by our current understanding of physics. Great for a captivating story, not so great for scientific accuracy.
Okay, I think I see where you're going with this. So you've got these natural scenarios, like our black hole example, that are theoretically possible, but maybe only good for a one-way ticket to the future. And then you've got this Wellesian time travel, the kind we see in movies all the time, which is definitely more exciting, but maybe totally breaks the rules of reality. But what about all the paradoxes? I mean, wouldn't going back in time just mess up the entire space-time continuum or something like that?
You're talking about things like the grandfather paradox, right?
Mhm.
It's a classic thought experiment, not so much a scientific theory. But it does highlight those potential logical contradictions that come with the idea of traveling to the past.
It's like, if you could go back in time and prevent your own grandparents from ever meeting, would you even exist in the first place to go back in time? Makes my head spin just thinking about it.
I know, right? And that's just one example. There are tons of other potential paradoxes and contradictions that pop up when you start to really dig into the implications of changing the past. Which is why some physicists and philosophers believe that any time travel to the past, if it's even possible, would be seriously restricted by the universe itself.
So what you're saying is the past is fixed. And even if we could go back, we wouldn't be able to actually change anything.
That's one way to interpret it, and this is where that concept of compossibility comes in, something we came across in that Internet Encyclopedia of Philosophy article.
That was a surprisingly easy read, by the way. I was expecting something way more dense and complicated.
Tell me about it. It was surprisingly digestible.
Mhm.
But anyway, compossibility basically means that what can happen with time travel is limited by what's already gone down. The past is fixed, a done deal. You could maybe go back and see it for yourself, maybe even interact with it in a limited way, but fundamentally changing it, not going to happen.
So it's like watching a movie. You can rewind and watch certain scenes again, but you can't actually change the plot no matter how many times you hit rewind.
Perfect analogy.
Yeah.
And that leads us to what's called the Novikov self-consistency principle, which basically says that any action a time traveler takes in the past, it has to already be a part of how the timeline plays out. In other words, let's say a time traveler actually did go back and try to change something. Those actions would have already been factored into how history unfolded.
Whoa. So even a time traveler's actions are kind of predetermined in a way. That has some pretty big implications when you think about it. It's like, if you can't change the past, what does that even mean for free will?
It's a question philosophers have been wrestling with forever, and time travel just throws another wrench into the whole thing. It definitely challenges our whole idea of cause and effect, that's for sure. But even if we take this Novikov self-consistency principle as a given, a time traveler's actions, they're still a part of that predetermined timeline. It's not that they don't have any influence at all. It's more like their influence was always meant to be. You know what I mean?
Okay, so it's less about rewriting history completely and more about causing ripples in the timeline. I kind of like that analogy.
Yeah, exactly. Ripples in a pond. Their actions might cause these little ripples, but the pond itself, the overall timeline, it stays the same.
This whole conversation, it's giving me some serious Back to the Future vibes, you know? And speaking of Back to the Future, it brings up another thing, the Fermi paradox. If time travel is actually a thing, and let's just say, hypothetically, some super advanced civilization in the future cracks the code, where is everyone? Shouldn't we have time traveling tourists running around trying to get selfies with historical figures?
Now, there's a question that's been keeping scientists and sci-fi writers up at night for years. The truth is, there's no easy answer. But there are some pretty interesting possibilities out there. One idea is that these advanced civilizations, even if they figured out how to time travel, maybe they've chosen not to. Could be for ethical reasons, practical reasons, who knows? Maybe they are observing us, but doing it on the down low, like a bunch of cosmic historians being super careful not to mess with the timeline. Or maybe, just maybe, those limitations we were talking about, all the paradoxes, the laws of physics, maybe they're more restrictive than we realize. So, large-scale time travel tourism, sorry folks, not going to happen.
So like a cosmic version of the Prime Directive from Star Trek. Don't interfere with the less developed civilizations.
An intriguing thought, isn't it? The universe is full of mysteries, and time travel has to be one of the most captivating ones. But here's the thing. Even if we never actually manage to build a working time machine, the kind with flashing lights and a flux capacitor, even just exploring these ideas, it forces us to confront some really fundamental questions. Questions about the nature of reality itself, our place in this vast universe, even what it means to be human.
I'll say. My mind is officially blown. This deep dive, it's taken us from the everyday usefulness of GPS to the mind-bending world of black holes, even to the very nature of time itself. It's incredible how something that seems so theoretical can have these really profound implications.
And that, right there, is the power of scientific inquiry, of curiosity, pushing the boundaries of what we think we know. Right? It's not just about getting those clear-cut answers. It's about asking the right questions, even if those questions lead us down some pretty strange and wonderful rabbit holes.
And speaking of rabbit holes, I think we've stumbled onto a whole network of them today. For everyone listening, if you're as fascinated by all of this as we are, let us know. Hit us up on social media, send us an email, whatever works for you. What time-bending mysteries are keeping you up at night? Until next time, happy pondering, and thanks for joining us for another deep dive.